Alright, let's get our hands dirty. Before we even think about a single wire or screw, we need a plan, a really good one. What will the panel control or monitor? A robotic arm, a series of pumps, a custom brewing system, or even a lighting rig for your secret lair. Components you'll need: PLC, HMI, power supply, circuit breakers, relays, I/O and communication modules. Where will the panel live? Environment matters: clean room or grimy shop. Dust, metal swarf, moisture, oil. These define protection level. Choose an enclosure with the right IP, NEMA rating. Document standards compliance: UL, IEC, NEC or local regs. Write a mission statement. This is your North Star. Create a schematic using AutoCAD electrical or E-Plan. Also decide the look. We'll aim for matte black with neon accents. A deep, non-reflective matte finish helps contrast neon indicators. Neon-style LEDs improve legibility in low light. Define purpose, list components, check the environment, and write it down. You'll refer to this 100 times. Next, gathering your components and armor. With the blueprint in hand, it's time to go shopping. Gather the guts, PLC, the brain, and an HMI, power protection. Choose reliable brands: Siemens, Allen Bradley, Automation Direct. Plan I/O counts. Buy more than you currently need. Inputs like buttons and sensors. Outputs like motors and indicators. Spare capacity saves future headaches. Choose an HMI that supports custom graphics and high-contrast dark themes. This is where the matte black neon theme shines. Check communication, Ethernet, IP, Modbus, Profinet as needed. Use a dedicated 24V DC power supply for control circuits. Protect each major circuit with breakers or fuses. Main disconnect outside, smaller breakers inside. The enclosure is the armor. Choose the correct NEMA IP rating. For dusty shops, choose NEMA 12 or IP 54 as appropriate. Then finish it matte black for contrast with neon controls. Select LED illuminated push buttons and indicators for low light clarity. Don't forget terminal blocks, cable ducts, and DIN rail. Make a complete shopping list and check off every part. Pack everything, label boxes and organize parts for assembly. Next, from bare metal to a symphony of wires. The parts have arrived. Lay them out before you touch the enclosure. Arrange components on paper or bench to validate spacing and heat management. Place heavy items like the power supply and PLC where they belong. Measure twice, mark precisely, and use a center punch before drilling. Start with a pilot hole, step up to final size for clean cutouts. Test fit the HMI and buttons before final assembly. Secure DIN rails firmly to the backplate. Snap PLC, terminal rows, breakers and power supply into place. Mount wire ducts to route wiring cleanly. Follow color codes: black =sign hot, white =sign neutral, green =sign ground, blue =sign DC common, brown red =sign plus 24V as your scheme dictates. Cut to length, crimp ferrules, and insert into terminal blocks. Run wires neatly in ducts. Leave service loops for maintenance. Connect every metal part to the main ground. This is your most important safety feature. Attach backplate and door to chassis ground points. Perform pull tests and tighten every terminal methodically. A well-organized layout reduces noise and makes troubleshooting easier. Patience here pays off in the final aesthetic. Install illuminated push buttons and verify HMI fit, style and function in one. Next, programming the PLC and HMI. The panel is built, a monolith of black metal and pristine wiring. Now give it a mind. Start programming the PLC. Use TIA Portal, RS Logix, Codesys, whatever matches your PLC. Write ladder rungs. If input, then output. If this push button input is on, then turn the motor output on. Comment your logic. Tell a story for the future you. Implement safety interlocks and test e-stops in code. Divide code into clear sections for manual, auto, and fault handling. Design the HMI, black background, neon accents, minimal clutter. Use vibrant blues, cyans, magentas, and clear white numerics for contrast. Create tags and bind HMI elements to PLC addresses. Set up network, Ethernet, IP, Modbus RS 485, or Profinet. Configure IPs so devices find each other. Set IP addresses and test communication. Link the start button to the PLC start tag and watch the action happen. Bind numeric displays to PLC variables like motor speed. This is how touch becomes a real-world action. Document code, export HMI screens and keep a parts list. Back up your program off-site. Now, the most critical phase, testing and documentation. Before power, perform a dead panel continuity and ground check. Verify grounds and no shorts between power and neutral. Catch wiring mistakes now. It's cheaper than smoke later. Wear PPE, stand to the side and have the main breaker ready. Apply power slowly and watch for expected boot sequences. Do the PLC and HMI boot cleanly. Press every button, flip every switch, verify start and stop. Test the emergency stop. Does it kill outputs immediately? Simulate faults and check fault handling routines. Follow a written functional test plan and mark every step. Verify that operator actions match machine responses. Photograph wiring and export code snapshots for records. Create full electrical schematics, BOM and printed PLC HMI listings. Place a binder with documentation to live with the panel. Good documentation makes future maintenance fast and safe. Design for expansion. Add spare space and tags for future modules. Consider adding an IoT gateway for remote monitoring. Send telemetry to the cloud and enable push alerts for faults. Implement LOTO procedures for safe maintenance. Label every wire, both ends, and every component for fast troubleshooting. A great panel is built to perform, to be understood, and to last. Thanks for watching. Like, subscribe, and build something amazing.